Hello everyone, welcome to this tutorial. My name is Amir Sinahrari. I'm a Google Earth Engine expert. In this tutorial, I'm going to show you how to calculate built-up area change percentage in the Google Earth Engine platform using Python API programming. So, in the first step, you need to go to the Google Colab environment. The Google Colab is a platform allows you to run machine learning algorithm using Python language. And here it is very easy to make a bridge between Colab and Google Earth Engine and integrate Python and Earth Engine capabilities. So let's get started. Here, import Earth Engine libraries, import EE, and import GEE map as GEE. As you can see here, two libraries, Earth Engine and Google Earth Engine map imported. Let's run it and make another cell to run another part of your code. In the next step, we need to make a bridge between Earth Engine and also the Colab environment. Actually, we want to have access to our account in the code editor using Python language. So let's start with authentication first. Earth Engine Authenticate. From Earth Engine library already imported, run authentication and then initialize like this the actually cloud project that is connected to your Google Earth Engine. Here in the upper right, go to the account and click on project info. As you can see, the cloud project that's connected between Google Earth Engine and also the cloud environment is available here. Just copy and paste it here, just like this. The project name is like that. So this name can be different by users because every one of us have a single username for the Earth Engine account. So run this part, and now the Colab environment asking you for connection with your Google Earth Engine account. Select your account, click on continue and continue. So it's done. Now we have access to Earth Engine capabilities in the Colab environment. So in the next step, I'm gonna set my study area first. So through the code editor, it is very easier to find the region of interest and copy and paste the coordinates into the Colab environment. For example, in this study, I'm gonna work on Iran's capital, the Tehran. You can use this tutorial for your own city or your own region of interest. The data, platform, code, and everything is public and freely accessible for all the users in all around the world. So let's draw a rectangle for the region of interest, like this, for example. In the next step, we need the coordinates of the rectangle. Let's print geometry, geometry.coordinates. That allows you to get the coordinates or list of coordinates for the rectangle. So a new variable as coordinate created in the Colab environment. So now first we must make a list of coordinates and then convert it to the polygon or identified polygon for the Earth Engine libraries. So let's grab the coordinates and paste it into Colab, just like that. If you want to say the code continues in the next line, use the backslash like this. Again, do the copy and paste for the rest of the coordinates, just like that. It is very easy. I'm trying to show you the simplest way to deal with Python language for actually having access to the Earth engine. So there it is, step by step, no rush. And the last one here, coordinate is available. So there it is. We have a list of coordinates for the region of interest. Let's print the coordinates, and now you can see there is no syntax error in the coordinate variable. In the next step, we need to convert it to a polygon or geometry that is known by Earth Engine libraries. So a new variable as, for example, ROI created. ROI equals to Earth Engine dot geometry dot polygon, just like that. Dot polygon allows you to convert the list of coordinates to a polygon or drawing polygon. So let's run your code, and here instead of a list of coordinates you have a polygon with 5 vertices, and here you can have you can see the rectangle with the same structure you already seen in the Earth Engine environment. So this step is done. In the next step, I'm gonna show you how to see your region of interest using a simple GUI interface in the Python language. Because in the Python, we don't have access to the interactive area like what we have in the code editor environment. So, but thanks to the existing libraries such as Earth Engine and GEE map, here we can make this easily and without any challenge. So a new variable map created. So from GEE library dot map, you can call the map functions through the GEE libraries. The base map for the background could be hybrid or satellite. Allows you to have a satellite view for the background. So then we want to have focus on the study area through the map.center object. Map.center object focuses on ROI. Then map.addLayer shows the region of interest on the map. So leave the visualization parameters empty and the layer name set it as ROI. Let's run a map to see the interactive area for the region of interest. As you can see, we had focus on a study area that is Tehran. If you go to the satellite view, you can see the same area that is selected in a Python language. So the study area selected here and easily accessible. In the next step, I need to call the satellite data from Earth Engine catalog dataset. So in this tutorial, I'm going to use GHSL products that provide wonderful information for urban area monitoring and studies. So if you want to find this data, just browse the data catalog first. Go to the tags and look for GHSL product, Global Urban Monitoring. So this dataset is available with different information. The target one is Global Built-Up Surface Area, available from 1975 to 2030. That is a very useful things to monitor built-up area changes in the urban environment. Go to this product, and here the product description gives you a lot of information about the source of data and data characteristic, bands, spatial resolution, and dataset availability, and also the center of data, or the source of the data actually. So now we want to call this product in the Python. It's very easy. Thanks to existing libraries, you can handle Earth Engine in the Python environment without any challenge, and same time you can have access to extra algorithm that is not available in the code editor. In this tutorial, I will show you some of these capabilities. So just copy and paste the Earth Engine snippet for this data. The urban product or built product or built up area equals to Earth Engine image collection. As we already connected to the Earth Engine image collection and data catalog connection already created. So now let's run a code and see how many data is available. 12 elements available in built variables. Go to the feature, and here the data is listed since 1975 to 2030 with 2 bands. Go to the bands and properties here. You can see the band's name and characteristic here, and also easily accessible for you. So let's select the target band. There are 2 bands here. One of them built surface, built up surface for residential areas, and the next one is specified for non-residential built up spaces. So we want to focus on built surface. It's totally up to you which one of these bands selected. So built surface selected, and dot select, same as code editor environment and JavaScript, allows you to select the target band. Let's run the code again. Again, you will have 12 elements, but this time only 1 band for each date is available that shows the built-up areas. It is also possible to visualize the dataset thanks to GEE map library functions available here. So let's do the visualization for this product and get more understanding about the data information, about the kind of values we have in this product. So make a stack layer first, put all the bands into a single image, get built image collection and convert it to a stack layer using 2 bands. The same function is available in the code editor environment. Go to the docs, and here just type 2 bands, just like this. If you go to the 2 bands, there are enough information about how it is working and how you can use this. So the same structure is going to be used in the Python environment. Then you can clip it based on region of interest, ROI, already created. If you go to the clip in the doc, here you can see how to use the clip structure. The same structure can easily handle it or manage in the Colab environment. So let's run a stack layer, and here you will have 1 single image instead of 12 images in an image collection. You have 1 image with 12 bands, and as you can see, each band shows the built-up area for 1 single year, 1975, 1980, 1985, with 5 years interval. So the stack layer created. How to visualize it? Let's run the map.add layer. So actually stack layer comes here as a main object and leave the visualization empty, and the layer name could be stack layer. So let's run a code, and once the code completed, back to the interface environment or the map you already created. Here you can see the ROI and a stack layer. The stack layer is available, and now you can actually turn it off for one layer or turn it down. So let's go to the layer setting to increase the contrast here. So as you can see, for example, you can select 1 year and stretch the contrast with 90% of values and increase the contrast here. There it is. As you can see, this is the visual characteristic of this product that shows residential areas with a bright color and separated from non-residential areas or other impervious areas over the cities. Now in this tutorial, I'm gonna show you how to calculate the area of urban structures or residential areas, and how you can calculate the percentage of change for each 5 years separately. That could give you more insight about the time series and changes. So let's back to the code. Now here, make another code environment, and in this is make another code cell, and now I'm gonna show you how to make a function to calculate the area and extract the area and date for each existing image. In the Python, when you want to make a function, the DEF at the first should be used. DEF, so the function is, for example, extract area. So the function has one input or argument, that is input images. Now the colon allows you to run or write the body of your function. So first we want to calculate the area. As you remember in the code editor in the previous tutorial, whenever we wanted to select an area, actually we used whenever we wanted to calculate the area, first we have to set a threshold to separate the target values or residential areas. Here we have a threshold. Same structure or same procedure is going to use here with a little bit change. So THR equals to, from each import image, for each input actually, select pixels dot gt. We already have it in the Earth engine. Dot gt. The values greater than a threshold. Values greater than 0 considered as a residential area here. Then we need to mask out the 0 values from the threshold. So the thr.update mask. So the main difference, maybe you get a little bit confused for the code in the Colab environment, because for example when you write update mask, maybe you cannot see the rest of the code same as what we have in the actually Earth Engine environment. For example here, if you write the update mask, for example, or something, for example when you write the coordinates or any function, if you press on Control and space, you can see the rest of the code like this. But it doesn't work in the most of the time. It doesn't work in the Colab environment. So to avoid any potential mistake, I'm suggesting you to double check the function's structure and also the writing style in the doc environment. For example, about the update mask here, you can check how to write it. Update mask, which letter is capital, which letter is non-capital, so just like that. That helps you to avoid any misunderstanding and syntax error while you are coding in the Python environment. That update mask again for the threshold. That allows you to get rid of no value pixels or non-pixels. In the next step, we need to calculate the area of existing or remained pixels. The area equals to get mask image, multiply Earth engine dot image dot pixel area, the same function we already utilized in the Earth engine. Again, came here to calculate the area for mask. So the area of each pixel calculated, but now we need to actually get some of the areas for each year separately. So extract, or here we can extract the sum of the areas by value or val variable. So get the area image and use reduce region. The reduce region allows you to calculate the sum of the areas for the region of interest using reducer operators. Earth engine reducer.sum, geometry equals to ROI, and scale equals to 30. So if you go to the docs here, you can see the necessary arguments and optional one. But remember to change the scale to 100 because the spatial resolution for this product is 100 meter. So now the value extracted. If you want to have the actual values, just dot values helped and get the first item in the dictionary structure. The reduce region returns a dictionary format. Dot values and get allows you to convert the dictionary style to the value style that is necessary for further analysis. The next variable is date. For each value, we need a date in our database. So from each image, get the date value with a normal format, year, month, and day. Finally, the function return a feature collection for the feature collection that includes two columns. The first one is date and another one is area. So keep the spatial information as none because the spatial site doesn't matter here. Only we need the area and year for each record of the database. So the first column is the date, could be equals to the date, and the next one is area equals to value. Okay, let's run a function, but the function doesn't work until we apply it on existing data. If you click on variables here, you can see all the variables already created. If you actually keep your mouse actually on the name of each variable here, you can have a preview about the data structure. That could be very beneficial to know which one of the variables should be used in the next step. So here we need to apply the extract area on built image collection. Let's make a new variable. Here is built area equals to, so get or bring the built images and then make a loop structure using a map and apply extract area just like that. Finally, we need to check out the output. The built area, an image collection imported, and the output is a feature collection, as you can see. For each feature actually included two properties. The first is a year and correspond area for the same year with a square meter unit. We can change the unit to the square kilometer. I will show you in the next steps. Okay, so in the next step, I'm gonna actually do some sort of further analysis here. This is the step actually in the Colab that we can integrate or get assistance from Python libraries. For example, in the Google Earth Engine code editor environment, you can only plot the area value changes. That's enough. But you cannot do further analysis for the time series data. But thanks to the Colab environment, it is possible to integrate Earth Engine capabilities and machine learning algorithm. For example, here I'm gonna get these values to calculate, for example, the urban change percentage easily. And also I have a lot of facilities or unlimited facilities here to do unlimited works and calculate unlimited indices. That's very beneficial in the Python environment. That's why sometimes we prefer to use the Colab because it is more flexible, provides more facilities, and I'm suggesting you to try to learning step by step. So now we want to make a data frame in which two columns shows area and corresponding date for each. So let's extract now in the next step. We need to extract date and area as two different as two different or separate variables because we don't want to have them inside a feature structure. For the data analysis and machine learning analysis, it is better to have our data properties inside a data frame structure. So now we need to make a list from area values. Area list equals to get the built area. The feature collection included the area and dates. So built area dot to list allows you to make a list. So this list, the number of rows depends on size of built area. Dot size dot get info, then area list. Let's run a code, and here you can actually break down the feature collection and see the properties and for subclasses and parent classes easily. For example, here under properties we have area and date. In the next step, I'm going to show you how to get area and date as separate variables. So date equals to, make a bracket. So from the items in the properties, here you can see we have properties. I have access to the items under properties. So the properties included area and date. The next bracket used for the date items. So date for item in area list. So there it is. As you can see, this structure or this code easily help us to get the items available under the date and return it as a list of value. Let's print the date, and now you will have a list of the dates. We're supposed to use the same structure for the area. Area equals to items under properties and areas for item in area list. Area. A was missed. There it is. Now you have a list of dates and list of areas. In the next step, we want to integrate them into a single data frame. So now we can use the other facilities or extra facilities available or provided by Python. Now we can call new libraries like pandas or pandas as PD and import numpy as np. Pandas provides numerous tools for data frame structures, data analysis, and the numpy used for linear algebra analysis. Make another environment code cell and define a data frame. From pandas, call or make a data frame included two columns, the date and for example area equals to the area. So let's print the data frame. Here you have a data frame or Excel file or something like that shows the date and correspond area from 1975 to 2030. But for the further analysis, we need to do some change in the data frame. The first is about the index. Actually, the dates, although the dates are available here, but it is not readable by algorithm in the Python. We need to change them into a standard format for the further analysis. And the area values, this is based on a square meter. It's a little big and it's hard to understanding. We can actually convert it to the square kilometer. Let's start with the date conversion. So now we want to convert the date to a readable structure. PD dot to date time from data in the data frame date. So then data frame index created df.set index as date. Let's print the df index now. As you can see, the date converted to a readable format for Python. And now we can convert the areas from a square meter to a square kilometer. It's very simple. Just divide values to 1 million. This is a constant value, constant coefficient to conversion between a square meter and a square kilometer. So let's run a code, and the values now is smaller and easy to understand. But there are a lot of digits here. You can reduce it to only 2 digits by round function. As you can see, it is very simple in the Python. If you want to round the list of values, you need to write more codes in the code editor environment. But thanks to the Python pandas libraries here, you can easily manage your data frame and easily you can handle data processing steps. So the area and date extracted from the satellite data. In the next step, for example, imagine that you want to get export and actually you don't like to continue. It's totally up to you what kind of process you do in the Colab environment. Now I will show you how to get export from this table, and then In the next step, I will show you how to calculate the percentage of change here. Okay, now we have a data frame that is indexed, that is actually already defined by index date. To CSV allows you to get it as a CSV file. So data frame index, you can have area or built area. This is a name actually. Built area.csv for Tehran city. Let's run a code. In the left panel, go to the files, and as you can see, the built area is available. If it wasn't, just click on refresh. The built area is available, and you can have a preview here. Let me to make it a little bigger space here. Now you can see the dates and area for all the years available in this data set. So if you want to download, just click on download, and after a few moments the data built area for Tehran with the CSV file is downloaded easily. This is with CSV format, and you can actually download it easily in the in your system. So now in the next step, I'm gonna show you how to calculate the residential area change percent. Actually, the change percent could gives you more information. Okay, for example, now let me to plot data frame index to see how residential area changes. As you can see, the residential areas from 1975 to 2030 actually increasing, has an increasing trend. This is a linear increasing, and also most likely it is a significant trend. But now we don't know how many or how much change based on percentage value occurred for each 5 years. For example, how much percent urban area increased or urban area decreased from 1 year to another year, or is there a same change percent for every 5 years? These are the questions that gives you to actually present more insights about the variations or about the area monitoring, because in the remote sensing we're not supposed to use the data to only plot a variable. We want to do some sort of data analysis to get more concrete examples and concrete informations to highlight the details, not only the general information. So here I make a text to show you the equation. The change percent for each year equals to, we have there are a couple of parentheses here. We have a division. In the numerator, the current year value must be subtracted from the previous year, divided to the previous year values. So this is an equation for change percent, as you can see. But the problem is we have the current values, but we don't know how to get the previous values. For example, the current value should subtract it from previous values, divided to the previous one, and multiply to 100. So this is a little bit difficult here, but now I'm showing you a simple structure that allows you to do this calculation. So now make two variables, current and previous one. Data frame index dot copy. This is the current data, and the previous one equals to df index dot shift 1. Actually, the shift allows you to make a shift down to the values. So the current is current, same as data frame index, nothing changed. Just we made a copy from the data frame index with another name. But the previous one actually shows the values that one record actually came down here and as a shifted down actually. For example, 781 already was the first record and now came to second record here. All the values 1 unit shifted down and now we have the previous values. So in the next step, just run or write this equation. It's very easy to calculate. The current data frame subtracted from the previous data frame divided to the previous one, multiplied 100. Make another cell code environment, change equals to, okay, write the same one. Numerator and denominator. The current data frame subtracted from the previous one, divided to the previous one again, multiplied to 100 because we want to show the percentage of change. So let's see the change. Actually here you can see for each 5 years how much a residential area changed. 1% sometimes compared to the last 5 years, and sometimes only 2% compared to previous years. Actually, now we are calculating the change percent based on the previous year value, each year compared with the previous one. Okay, and now make another code and the change plots that shows you how actually urban area changed based on percentage. For example, here we can see around 2.5% urban area changed in, for example, 1995 compared to 1990, and also the slope of change actually was bigger in between 1990 between these 2 years, 1990 and 1995. So there it is. And sometimes we had a bigger change, and sometimes we had a lower change values. Yeah, and now compared to the previous one that showed a simple increasing trend, now you can explain how the residential area, how much actually developed compared to the previous 5 years. There it is. And you can use actually this equation to do the same calculation with a bigger shift. Here we used only 1 year shift, or 1 record shift. You can also increase the number of shift to see to analysis the change percentage in the bigger scale, in the bigger time scale actually. I hope you like this tutorial and I tried to give you some insight about built-up area monitoring in the Google Earth Engine platform. There are also other tutorials about Python programming language on my YouTube channel, and I'm highly suggested to follow that tutorial to learn more and more how to use more facilities while you are dealing with the satellite data. If you had any problem and question about the code link is available below this video in description box, and feel free to reach me out on my YouTube channel and share your comments there. Thank you for your attention.